Last time we set everything up and created our first images. Now we begin exploring our core toolkit. In this chapter, we'll dive into essential transformation methods, Img2Img, Redux, Inpainting, Controlnet, as well as prompt generation using vision and language models. These will become your main creative tools going forward. Let's explore the concept of Img2Img. This type of workflow lets you transform an existing image by applying a new prompt. You can adjust the denoising strength, lower values for subtle edits, higher values for more dramatic changes, while still keeping the original structure intact. The only difference from the text-to-image workflow we covered earlier is that instead of creating a latent image from scratch, we load an existing image and encode it as the input. Here, my denoising value is set to 0.70. If it were 0, we'd get the original image back unchanged. If it were 1, we'd get a completely new image based entirely on the prompt. Let's run this workflow and see what we get. It definitely retains some features from the original image. Now, let's increase the denoising value and observe how that changes the result. Now this is closer to my prompt, and it still retains some features from the original image. Let's take a look at the Redux model and see how it differs. While Img2Img focuses on creative transformation, loosely preserving the structure, but allowing bold stylistic changes, making it great for reimagining and artistic edits. Redux prioritizes structural accuracy and realism. It produces cleaner, more controlled results, making it perfect for refinement, portraits, or precise edits. Let's run this workflow. Here's our new image. It completely preserves the structure while giving us a different variation. Let's run it again. As you can see, it's a very powerful tool. Now let's explore the Inpainting workflows. This is a basic Inpainting setup where you edit or regenerate specific parts of an image while leaving the rest untouched. Now, let's change our character's medallion together. First, we'll right-click the Load Image node and select Open in Mask Editor. Then, we'll paint over the medallion area we want to modify. Once that's done, we'll give a prompt describing what we want in that specific masked region. Just remember, this prompt only affects the mask part, not the whole image. Click Run, and let's see the result. We've successfully inpainted the medallion. That's our updated image. Now let's move on to Outpainting. Outpainting is the process of expanding an image beyond its original borders using AI. We're padding our image by 256 pixels on each side and using that as a mask. Then, we provide a prompt to guide the generation. You can also leave the prompt empty to let the AI imagine the surroundings freely. Let's take a look at Controlnet next. Controlnet is a neural network technique that lets you guide diffusion models during image generation using additional inputs, like sketches, poses, depth maps, or edges. We've applied Open Pose, Depth Map, and Canny Edge processors as pre-processing steps to our input image. Then, we used the prompt an ultra-realistic photo of a warrior. These are the results shown in order. Let's begin by looking at the Open Pose output together and see how it guided the composition. Notice how it perfectly transferred the pose from our original image. Since it only references the pose, it has more creative freedom with the character's appearance. Now let's analyze the other results. The depth map offers less creative freedom compared to Open Pose. pose. It closely follows the shape of the original, setting clearer boundaries. Because of this, the new image generated with the depth map is more similar to the original than the one using open pose. Lastly, our Canny Edge pre-processed image allows even less creative freedom. Because of the dense lines from Canny Edge detection, it's harder for the model to synthesize new shapes. Notice how it preserves more details compared to the other preprocessors. Now, let's analyze vision language models. It's a type of AI designed to understand and connect both images and text together. Let's take a quick look at how it works. Here, it generated a caption for our image. We can use this caption later as a prompt in our pipelines, which is much more convenient and effective than writing prompts manually. You can also select a more detailed caption, run it, and get even richer descriptions. Let's look at Janus Pro, another vision language model. I like Janus Pro because it creates more detailed and creative captions. For quick and simple captions, I use Florence. But for richer, more nuanced descriptions, Janus Pro is my go-to. With the Janus Pro node, we can ask very specific questions or give detailed instructions to the model, making it more flexible than Florence. Let's move on to large language models. This search LLM node uses the Mistral 7B Instruct model, which is a large language model. LLMs are AI models trained on massive amounts of text data to understand and generate human-like language. We're going to use this node to enrich our prompts. Unlike vision language models, the input here is text, and the output is also text. Lastly, let's check out the Bjornulf text generator nodes. Thanks to Bjornulf, we'll be using many of his nodes. What we do here is adjust the parameters we want, and each time we run it, the node generates random values. This lets us create complex pipelines with varied, rich prompts quickly. When set to random, it picks a new value on each run. If left none, that parameter is excluded from the prompt. Changing these values helps us get diverse results fast. You now hold a complete set of editing abilities. Replace parts of images, guide generations with poses or sketches, and generate prompts automatically. In the next chapter, we'll move into full character creation and identity control. Prepare your spells. We're bringing characters to life next.